Now, having gone into fundamental laws of Bohr's atomic model or the assumptions on which this atomic model is based, let's enter into certain calculation. As I told you, all calculations will be manipulated through law of circular orbit and law of quantization of angular momentum. The very first calculation that we are going to do is regarding the energy of the system. Now, when I say system, so atom is taken as system. Now, atom means nucleus plus electron. So, we are considering the situation when we have our electron revolving in an orbit and its principal quantum number is n. So, we intend to make calculation for energy of electron. Now, that's a very loosely used word. When we say energy of electron in nth orbit, we are actually talking about energy of system. And remember students, our system is atom, and atom means nucleus plus electron. So when we say energy of electron in nth orbit, it is not the energy of electron, it is the energy of system, that is atom, when electron is revolving in nth orbit. So let's make calculation for energy of system when electron is revolving in nth orbit. Now we intend to make calculation for the total energy. Now here total energy refers to kinetic energy and potential energy. Now we have to remember one thing while applying Bohr's atomic model in any situation, that all classical laws of mechanics are valid when electron is revolving around nucleus, that is in stationary orbits. But when electron makes a transition from one energy level to another energy level, the laws of mechanics do not hold good, and it is quantum mechanics which takes over. Remember student, there is a very crucial point. While applying Bohr's atomic model to any situation, do remember that when electrons are revolving in stationary orbits, the laws of mechanics are valid. But when electrons makes transition from one energy level to another energy level, the laws of mechanics are no longer valid. It is quantum mechanics that takes over. So let's enter into calculation of energy, and here the potential energy of system. So we'll be talking about two types of potential energy, that is, one is the electrostatic potential energy and the other is a gravitational potential energy. We'll be ignoring gravitational potential energy because it is negligible as compared to electrostatic potential energy. We'll be ignoring gravitational potential energy as it is negligible compared to electrostatic potential energy. Also, we are assuming that nucleus is very heavy compared to electron. So literally we are assuming our nucleus to be at rest. So when we say kinetic energy of system, we mean kinetic energy of nucleus as well as kinetic energy of electron. So please look at the screen, and these are the necessary calculations shown. So here we write, now energy we are denoting it by E, and n is in subscript, and it will be equal to kinetic energy plus potential energy. As I said, nucleus has been assumed to be at rest and gravitational potential energy is being ignored. So we can write the expression for energy, that is En is equal to half mv square minus k ze square by r, where r is the orbital radius and k is a constant, which is equal to 1 over 4 pi epsilon naught, and z is the atomic number. Now, using law of circular orbit, we can write the expression, that is, we can write half mv square is equal to k ze square upon 2r, and that gives me the value of energy of electron in its orbit, and En will be equal to minus k ze square divided by 2r. Now, using law of circular orbit and law of quantization of angular momentum, so we find that there are two unknown in these two equations. One is the velocity and other is the orbital radius. Now we can make calculation by eliminating velocity term in these two equations, and we get the expression for radius, and it is equal to n square h square epsilon naught pi, that is divided by in denominator, pi m z e square. Now when we make substitution of this value of r in the expression for energy, we get the final expression for energy, and it is equal to m z square e to the power 4 divided by 8 epsilon naught square n square h square. Now when we make a substitution for the relevant constants, the final expression which emerges out, it is equal to, that is En is equal to minus 13.6 z square upon n square, and this energy is to be reported in electron